right, so today we're solving Leetcode problem number 165. It's a medium problem, but I think sometimes the Leetcode problems don't have the right rating, and I think you will see that it's actually quite an easy problem, or at least there exists an easy solution to it. So let's just read through it real quick to understand what the problem is. Given two version strings, version 1 and version 2, compare them. A version string consists of revisions separated by dots. The value of the revision is its integer conversion, ignoring leading zeros. To compare version strings, compare the revision values in left to right order. If one of the version strings has fewer revisions, treat the missing revisions as value 0. Return the following. If version 1 is smaller than version 2, return -1. If it's larger, return +1. And if they are the same, just return 0. Okay. So let's just understand what smaller and larger means. So here are some examples. If the first version is 1.2, then the first part, the first revision is equal, and the second is 2 and 10. So the integer value of 2 is smaller than the integer value of 10, which is the first case, so we return -1. Okay, so that is clear. Example 2. Here we return 0, so we say that these are equal, and that is because 1 is 1 is the same, and here 0, 1 and 0, 0, 1 are also the same because we have to ignore the leading zeros. So it becomes just 1 for the second part. Example 3. Okay, so now we have a different number of revisions in these strings. Here we just have 2, and here we have 4. And we output 0 because if revisions are missing, just assume that they have a value of 0. So this 1.0 becomes a 1.0.0.0 as well. Okay, cool. Constraints. Version 1 and version 2 are valid version numbers. Okay, that's good. So we don't have to do any checking. Version 1, version 2 only contain digits and dots to separate the revisions. And then we have some information about the length. The length is, because it's smaller than 500, everything will be constant time because the runtime is essentially independent of the length of the input if the input is limited. But we're going to do an analysis assuming that the length is not bounded by a value. So, and all given revisions are to be stored or can be stored as a 32-bit integer. So this is useful for people who code in C++ or other languages where you can have integer overflows, but we're going to use Python where we don't really have to bother with that. So okay, cool. So I would say that we should try to first normalize these strings, so to bring these two versions, to bring them in the same format. So one thing that we could do is remove all leading zeros, and another thing that we could do is just, make them both have the same number of revisions. And if we do that, then we can compare them by their values, by the revision values directly, and that will make it easy. So I'm thinking that we're going to have a runtime that is linear in the length of the longest version string. You could also say that n is the sum of the length of the version strings. It doesn't really change anything. So let's just write that down. Over n time, when is, well, where the length is just actually let's just say the length of version 1 plus the length of version 2. That's better. Because a string could have a lot of revisions or very few revisions and very large numbers here. So we want to take into account just the total length of the string, and that will make it easy. So yeah, linear time, and if we change or if we normalize these version strings, we're also going to need some space. So, and we're also going to need space independence of the length of the input. I think it's also possible to have a solution where we don't build actual string, where we don't normalize the strings, where you then have a constant space. That is also possible, but right now I'm just trying to do the easy way, which just normalizes the string. If you decide to do it without normalizing these strings, it gets a little bit more tricky with the indices and keeping track of what you're trying to match, which is more error prone. So in an interview, just show out the solution that is the easiest first, and then you can discuss, what optimizations you could do to this. Yeah. So let's see. So the first thing we're going to do is we're going to split the strings by the dot to get all the revisions. And so this is version 1, version 2. So I'm just going to do this. Version 1 dot split. So I'm going to split the string on the dot. And I'm going to do the same for the second string. So now we have them individually split. The next thing is to make sure that they have the same number of revisions. Yes, and we can do that with a very simple while loop. While, oh, and by the way, so this will give us a list. So this is no longer a string, this is going to be a list of all the parts that are separated by the dots. So while len of revision 1 is smaller than length of the revision 2, we're just going to append the value 0, right? Because that's what they said. Treat missing revisions as value 0. So that's what we're going to do here. And we're going to do the same for the other case where revision 1 is larger than, is longer, or the number of revisions in the first string is more than the ones in the second string. In this case, we have to append a 0 to the other string. So we can just do this. Yes. Now the next step is to get rid of these leading zeros. And it should be quite easy too. So now that our revision arrays have the same length, we can actually iterate over them in parallel. So let's see. I'm going to call now these individual revision values ref1 and ref2. And I'm going to use a little Python function here, zip, which is able to combine different lists into, well, can iterate over multiple, it kind of, well, how to explain this best, zip can be used to basically iterate over two arrays in parallel like this. So it kind of combines them. I think it actually packs the elements from the first and the second into a new list. I'm not quite sure. It would be nice to read that up, to how zip works internally. But as far as I understand, it just makes it easy to iterate over both lists in parallel. I could also use an index to do that, but why not use a more Pythonic way to do it? And I don't think zip builds a new list, so it doesn't create any overhead in terms of needing extra space or whatever. But I could be wrong. Look it up. Actually, in an interview, when you can explain that, that's probably a good thing. So yeah, definitely look that up. So, but I'm just going to use it here. So what we do now is we're going to check how many leading zeros each of these has. And if they have any, we should remove them. I'm going to do it in a lazy way here. So I'm just going to do while the length of the string is larger than 1, right? Because if we have only one zero, it's not a leading zero, it's just 0. So we need to make sure that our string has the length larger than 1, and that the first position of the string is equal to 0. If that is the case, we could say rev1 equals just the string without the first character. So this actually creates a new string, which means we are needing some extra space. To make it optimal, we would probably use an index. Yeah, maybe we should just try that. So for I in range length ref -1, because we want to leave a last zero, potentially last zero standing. So now we need to check if ref1 at position I is not 0, then we're basically done. And we can say that ref1 equals ref1 starting from position I. And then we'll just break. Right. And finally, let's see what happens at the end here. So when all of them are 0, then then we will never truncate this. So if it's unequal to 0, we will break. But we should also probably check if we're at position length of ref1 -1. That means we've iterated over through the whole thing, and all of them were zeros. So we actually have to take care of the case of when we reach the end of the string. Maybe we should start like this. I is equal to 0, while I is smaller than this, and ref1 is unequal to the character 0. And while we do that, we increase our value I. And then at the end we can say ref1 equals ref1 starting from position I. So that means when the first character is not a 0, we don't even enter the while loop, and the value of I is 0, so we don't actually change the string at all. And when we reach the last position in the string, like here, when we reach the last 1, which actually our value of I will stop exactly before the last position, before the last digit. And in this case, we know that I will be the length of the string -1, so only the last character will actually be included when we do this, which is exactly what we want. Now we have to do the same thing again for revision 2, and because those are 4 lines of code, something that you can always do is you can create yourself a little helper function. And that's sometimes really nice in interviews when you start to modularize your code a little bit and group repetitive code patterns. It's not necessary, but it's an opportunity to show good code design. So if you make your code easier to read that way, that could help. So let's just write a function, remove leading zeros. We have a number string, and we're going to return that number string as well. So yeah, what we do is we just pack that in here. Oh, there we go. We don't deal with ref, we do deal with our number string variable, and we just have to return that. Return that. Yes. Yeah, so that should be good enough. If that's not readable well enough, you can also just do this. 0 is unequal to 0, we simply break. Right, so, and by the way, this, well, the type annotations are not really necessary. I think that's more like a thing here on Leetcode. In the coding here, you probably wouldn't do any type annotations. I'm just doing it to be consistent. And it also helps to copy kind of the coding style or the casing of functions when you're giving some starter code. Leetcode likes, for example, this style, but in other companies you might see a PEP 8 compatible style. So just adjust to the code that you see. That's usually the best thing you can do. Okay, so now we just have to remove our leading zeros here, and we just call our function here. Do the same for revision 2 value, right? And actually, right now we could actually compare these values, right? So we could say if int rev1, because we want to compare the numerical value of the revision, int rev2 of the first revision number with the second with one from the second version string. We can just do exactly that here. So we're basically doing this check right now. If that is the case, return -1. If the other, well, if the second case is true, then return the +1. This plus is redundant, but I like it because it keeps it easier to read. And finally, when we've checked the entire string, we just return 0, because that means both version strings are essentially the same after the normalization that we did. All right, so down here you can see that I've solved this problem before. What I did this time differently is that I added this little helper method here that ensures that we don't create a lot of new strings as we remove the leading zeros. So I don't know if this is actually going to work. Yeah, let's just go through this real quick. So first, we split our version strings into revisions, into lists of revision values. We then ensure that these lists have the same length by appending 0 revision values when they're missing. And in the last step, we remove the leading zeros from the individual revision numbers, like here, like so. And then we take the integer value of the first version string and that of the first version string, meaning the revision number in the first version string and the revision number in the second version string, do the comparison, return 1 or -1. And if we didn't find any difference here, we return 0 at the end. So I'm just going to run this test. Hopefully it works. Okay, so the test works. Nice. And again, these are exactly the test cases that we have here. And yeah, so I'm now going to submit it again. And boom, it works. Very nice. And just to show you the other solution that I tried first, submissions. So here you can see, so this is what earlier. I actually did it a couple years ago as well, but this is the one that I did earlier. And here you can see that in the final loop, I'm just instead of calling this remove leading zeros function, I'm actually creating a new string every time I see a leading zero, right? And of course that creates a new string every time, which is probably a little slower, but yeah. Anyway, so yeah, I hope that was a good enough explanation. You can also look at the solutions. Other people post solutions. That's also a little bit, well, it's also insightful. So here's one with O of one space. So that would be interesting to look at, because here we're building new strings, which takes, of course, more time. And yeah, maybe I create another version where I try one with O of one space as well. Now that would be a different